Welcome everyone, I'm Mr. Vaughn and this is a lesson overview. We're going to be giving you an introduction to proofs in this overview, and well, to get started we're going to look at a proof that's just an equation. We're given this equation and we want to prove that x equals 6. Well, before we get into the proof, we have this little caveat here, this little thing that we have to do for each proof. We have to have a reason for each step that we take in our proof. And a reason in geometry, reason has to be a property that we already learned. So they could be any of the properties that we know from algebra and geometry. Could be a postulate, could be a theorem, or a definition. Okay? So again, we got to use one of those for our reasons. Okay? And to start off with, we're just going to look at properties. Since this is an equation, we're going to deal with properties to solve it. We won't need postulates or theorems. Okay? So let's see what we do. In solving this equation, the first thing we do is we would add 15 to both sides, right? Okay, so that's kind of our first step, but that allows us to make another statement. And our statement is 8x equals 48. All right, then from there, of course, we divide both sides by 8. And when we do that, we get our third equation that says x is equal to 6. And there we've done it. We've got our proof. So we've got three different, that should be a 2. We've got three different equations that we wrote. So we're going to need 3 reasons to go along with each one of those. And the first reason, why did we write this equation down? Well, that's the one we were given. So usually in your proofs, your first step is going to be the given part. What did they give you to start with? Okay? Then our next step, step 2. Well, to figure out what our reason is, what we do is we find out what we did to our equation to get from this step to the next one. We added 15 to both sides. Okay, what's the property that allows us to add 15 to both sides of our equation? That is called the addition property of equality. Okay? It says you can add the same number to both sides and both sides will still be equal. So then how did we get from step 2 to step 3? We divided both sides by 8, and the property that lets us do that is called the division property of equality. And I'm shortcutting all that so we don't have to see me write a lot, okay? All right, so that's basically what a proof is, okay? Step and a reason. All right, so since we started talking about properties, let's review some properties of equality. We have the reflexive property to start off with, which tells us that any number a is equal to itself. The symmetric property tells us that if you have a equals to b, you could write that as b equals a. It means the same thing, okay? You can flip numbers across. In the transitive property, we have if a is equal to b and b is equal to c, then a has to be equal to c. For the addition subtraction, those two we kind of combine, and we have, if we have this equation a equals b, then the addition property says we can add c to both sides of it and it will still be equal. The subtraction property tells us if we subtract c from both sides, yep, it's still going to be equal. Multiplication and division are a lot like that. And once again, we have the equation if a equals b, then ac will be equal to bc. The product of a and c will equal the product of b and c. And as long as c doesn't equal 0, because we can't divide by 0, then a divided by c will equal b divided by c. All right. And just to let you know, because this is geometry, segment lengths and angle measures are also reflexive, symmetric, and transitive. Let's try to spell it correctly here. Transitive. Okay. What does that mean? Well, it means we could do things like in the examples here. Measure of angle Q is equal to measure of angle Q because of the reflexive property. If the length of AB is equal to the length of CD, then the length of CD equals the length of AB, and that's true because of the symmetric property. And finally, if the measure of angle G equals the measure of angle H, and the measure of angle H equals the measure of angle J, then the measure of angle G has to equal the measure of angle J. That is the transitive property. Okay. Now that leads us into what we're going to see most of the time when we're dealing with these proofs is what we call a two-column proof. Two columns, and we put the statements in one column on our proof, and we put the reasons for each statement on the other column. Okay? So for this one, we've got a proof. We're going to do a proof of the solution to this equation. And once again, we're given that equation, so given is our first reason. And what we need to do is we need to fill in each of these other steps with a property that we've learned in algebra. So I'd like you to go through, see how we got from step 1 to step 2, and write that reason in step 2. See how we got from 2 to 3, and write that reason in 3, and so on. And see if you can come up with all those reasons there. When you've got them done, just click continue. All right. To get from the first step to the second one, we had to use the distributive property. So that is our first one. And we haven't mentioned that yet, so maybe that's kind of a curveball for you. Okay, distributive property got us to that step. Then, in our next step, it looks like we subtracted 3x from both sides, so that is the subtraction property of equality. Then, in our next step, we divided both sides by 3 to get x all by itself. So that one is going to be the division property of equality. And then finally, in this last step, all we did was we switched places here. And that is called the symmetric property, again, of equality. Okay? And that's basically it. We've solved our equation. We've given a reason for each step or each statement in our equation. Now, of course, geometry, it won't be all about solving equations. We'll have to do geometric proofs. And they're going to look something like this. We're going to use this as our example. We're given that the measure of angle BAD, and let's kind of show that here. BAD is this angle, and that's equal to the measure of angle CAE, and that would be this angle. We're given that, and we want to prove that the measure of angle 1, that's here, is equal to the measure of angle 3. All right, so we've got this proof laid out. Now all we got to do is give the reasons. We start off with our given. The measure of angle BAD equals the measure of angle CAE. Okay, well, that's all right. Then in our next step, we kind of go off a little bit. The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle BAD. Now, that's true. Why can we say that? Well, that's the angle addition postulate. Okay, the angle addition postulate. All right, from there, their next step is the measure of angle 2 plus the measure of angle 3 equals the measure of angle CAE. That's exactly the same postulate. Angle addition. Okay? Now, since we have that, what we did with this next part was we took this expression and we substituted it in for measure of angle CAE, and we took this expression, we substituted in for the measure of angle BAD, and we get this equation. So that, the reason we can do that, that's called substitution. Property. And finally, what we did in the next step, we subtracted the measure of angle 2 from both sides. And that, of course, is the subtraction. Property of equality. Okay? So that's kind of what it's going to look like when we're doing some geometric proofs. But it's the same type of format. How did we get from one step to the next? We've got to show the step and give a reason for each step. All right, so this ought to be enough to get you going in this section. Go ahead and give it a shot. We'll see you along the way.